All right, so today is, what is it, Thursday, November 29th. This is period 3, and this is lesson 4.4.3. Solving by factoring. Okay, so step 1, set the equation equal to 0. It's already done. Step 2 is factor. What should I do? Good. The GCF is 11. Very nice. Let's GCF in 11. So I have q squared divided by 11 gives me q squared, right. Negative 44 divided by 11 is negative 4. Now what? It has 2 terms. What did you say? 2 step? No. Difference of 2 squares. Good. Alright, so the square root of q squared is q. The square root of 4 is 2. 1 minus, 1 plus. So I've done step 2, which is the factor. Step 3 is to set my factors equal to 0. So I'm going to do 11 equals 0. I'm going to do q minus 2 equals 0. And I'm going to do q plus 2 equals 0. Does 11 equal 0? No, 11 does not equal 0. So this one out here is an erroneous solution. It doesn't work. It's fake. Okay? That happens sometimes. The other 2 equations I have to solve. What's the solution to the green equation? 2 equals 2. What's the solution to the blue equation? Q equals negative 2. Good. There we go. Next problem. All right, the equation's already set equal to 0. I've done step 1. What do I do? Jessica, I'm so in love with you this morning. I'm so in love with you this morning. Deduct a couple points from Alyssa's grade. What? All right, so I'm dividing by 5n. The GCF is 5n. Yes, great. 45n squared divided by 5n. 9n. 10n divided by 5n is 2. How can I factor this stuff inside the parentheses? Okay. It is not the difference of squares. It is a sum. Is it a square? Oh, no. No. So in order to use the difference of squares, the variable has to have a power of 2. In order to use the sum or difference of cubes, the variable has to have a power of 3. So the stuff in the parentheses is not factorable. So here's another tough part about what you're doing. Not only do you need to know which factoring method to choose, you need to know when to keep going and when to stop.
So you have to multiply 5?
Nope, we're not going to multiply because multiplying puts you back exactly where you started. Okay? All right, so I am completely factored right now. All right? After I'm done factoring, step 3 is to take each factor and set each factor equal to 0. So I'm going to do 5n equals 0. And then I'm going to do 9n plus 2 equals 0. And I'm going to, that's step 3. And now step 4 is solve the equations. How do I solve the first equation? Divide by 5. So I have n How do I solve the second equation? 2. So I have 9n equals -2. And then what do I do?
Divide by
9. So my second solution is -2 over 9. I want to point something out right now. Yesterday, problem number 1. Almost every one of my students got problem number 1 wrong yesterday. Okay? And here's why. Problem number 1 had 4 solutions. See if you can remember this with me. 4, you made the mistake, Jessica. You got it wrong.
Negative
I
5,
didn't write it without trying.
4, 5, and 0.
0. Good, Sebastian. Almost every person.
I said 0.
Did you say 0? Oh. All right, Jessica's back on the hot shit list. I'm sorry.
Oh, there you go.
There are 4 solutions. The first solution was 0, and almost every one of my students overlooked the 0 when they were picking their correct
I
answer.
think 0.
You know you didn't.
Good.
I did. I did.
Miss Baruch,
So-
you were trying to sabotage me because you told me, yeah, that's the right one. When I showed you, you sure, Miss Baruch? Because there's a 0.
It is on there, as a matter of fact, but I figured we didn't need to listen to Sebastian argue. So, so anyway, so here my GCF was 5n, and that GCF gave us a solution. It gave us 0. In the previous problem, my GCF was 11. There was no variable in the GCF, and so that did not give us a solution. So the moral of that story is that sometimes the GCF gives you a solution, sometimes it does not. Okay, just be careful. All right, here's the next problem. This is going to be the last one of the day. It's already set equal to 0. Okay, so step 1 is done. What should I do?
3.
There's no GCF. Very nice. Now what do I do? I'm doing the X. Is this an easy AC or a hard AC?
Hard.
Hard. Good. So A times C is 36. I need factors of 36 whose sum is 12. What are they? 6 and 6. Good. What? Now this is a hard problem, so I can't just plug in. What's the next step?
Divide by 4.
Divide by A. Nice. Now what?
Simplify it.
Simplify the 2 fractions. Good. So taking a 2 out of top and bottom, this is 3 over 2, and so is this one. So now I'm going to do bottoms up. Okay. So I've got 2p plus 3 times 2p plus 3 equals 0. Good. So both factors are the same, right? All right. So you could, if you wanted to, write it like this, right? As a square. All right. So there's only one factor to this problem, okay? But that factor occurs twice. So I'm going to give you a vocabulary word. This factor has multiplicity 2. That's a vocabulary word that you're going to need to know when you take your midterm exam.
What is that?
It says multiplicity 2. When you take your midterm exam, you will need to know that word. When you take your midterm exam, I'm not giving you all the answers this time. Just FYI. I'm not. It was too easy. You guys already got your easy grade for the mark clear. All right. I'm going to take this one factor and set it equal to 0. What do I do to solve that? Subtract 3. That's 2p equals -3. Now what? Divide by 2. So So that gives me P equals -3/2. So P equals -3/2 is a solution of multiplicity 2. Got questions? All right, and that's all I have for today.